Hey everyone, and welcome. Today, we're jumping into a super important topic. How do we actually keep an eye on these incredibly complex AI systems? We're talking about the eyes and the ears of AI security, the monitoring and detection that makes everything else possible. So let's get right into it.
And just to be clear from the get-go, all the great material we're covering today comes directly from Chapter 6 of the AI Security tutorial from Virtualization Options LLC.
So, let's start with the big question, right? Think about it. Normal software is pretty static. You build it, you ship it, you know what to look for. But AI? AI is totally different. So how in the world are you supposed to monitor something that's designed to learn and change all by itself? That's the huge puzzle we're going to unpack today.
To really get our heads around this, here's our game plan. First, we'll talk about why monitoring AI is such a unique challenge. Then we'll lay out an architectural blueprint to get that visibility. After that, we'll dig into the key security indicators, what really matters. Then we'll look at how we spot anomalies, and finally, how we pull it all together into one integrated view.
All right, first up, the monitoring challenge. We really have to understand from the start that this is not your typical application monitoring. The very nature of AI makes this a whole different ballgame. You see, you can't just watch one thing. Real, effective AI monitoring has to be comprehensive. It's a multi-layered thing. You've got the infrastructure, the servers, the cloud services, then you've got the applications themselves. On top of that, you have to watch the AI models, their actual behavior, and of course, the data pipelines that are constantly feeding them. It's only by looking at all four of these layers at once that you can even begin to see the full picture.
Okay, so if the problem is that complicated, what does the solution look like? Well, that's where the architectural blueprint comes in. It gives us a clear four-step plan to get the total visibility that we absolutely need.
So here's how it works. Step 1, you just collect everything. All the logs, all the telemetry from every single piece of the AI system. Then you have to process that massive flood of data, cleaning it up and getting it ready in real time. Now, step 3 is where the real magic happens. You use analytics, often machine learning itself, to find patterns that just don't look right. And finally, step 4, you fire off smart, prioritized alerts and can even kick off automated responses to deal with a threat.
Now that we've got a framework, what are we actually looking for in all that data? Well, that brings us to the key security indicators. The best way to think about these is like the vital signs for your AI system. They tell you if it's healthy and, just as important, if it's secure.
Let's look at a few key numbers. First up, less than 2%. This is the magic number for how much a model's accuracy can drift before someone needs to take a hard look. Why so strict? Because that tiny little dip might not just be a performance hiccup. It could be the first sign of a data poisoning attack. That's why this is tracked so closely. Of course, a perfect model is useless if you can't access it. That's why the target for uptime is so high, 99.9%. For so many businesses these days, AI services are absolutely mission critical. So an outage, whether it's an accident or a denial of service attack, could be catastrophic. This number is all about resilience. And it's not enough for the system to just be on. It's got to be fast. The goal here is a response time of under 100 milliseconds. If your AI suddenly slows to a crawl, it could be a sign an attacker is trying to overload the system. So you see, latency isn't just about user experience. It's a massive security signal.
So when you put it all together, the model's health, its availability, its speed, you realize this can't be a 9-to-5 job. AI systems don't sleep. They don't take weekends. They are always on, always learning, always making decisions. And that means our monitoring can't take a break either. It has to be 24/7, continuous, across every last component. It's just not negotiable.
So, we're measuring all these things around the clock. But how do we turn all that data into actually spotting a threat? That brings us to our next section, detecting anomalies, which is all about finding that one tiny needle in a truly massive haystack of data.
Okay, this is really the core of it. Any big, complex system is going to have some noise, normal ups and downs in performance and usage. The whole game is about being able to tell the difference between that normal variation and a real potential incident, which is a sudden, sharp change from the baseline that could mean you're under attack. It's all about separating the signal from the noise.
So what kind of weird stuff are we looking for? Well, it usually falls into 3 big buckets. First, you've got model performance anomalies, like a sudden nosedive in accuracy. Second, there are usage pattern anomalies, maybe a huge spike in requests from a country you never get traffic from. And third, resource utilization anomalies, like the CPU or memory suddenly getting maxed out for no reason. Each one of these is a clue.
And finding these things isn't simple. It takes some pretty sophisticated tools. We're talking advanced statistics to spot tiny changes, and get this, we actually use machine learning itself to figure out what's normal and then flag anything that isn't. It's basically a high-tech game of cat and mouse.
Now, all this amazing AI monitoring is fantastic, but it can't live on an island by itself. It has to be plugged into the main security command center for the whole organization. And that brings us to our final section, integrating the view, which is all about something called a SIEM.
A SIEM, that stands for Security Information and Event Management, is basically the nerve center for all security data. For AI, it does 4 huge things. First, it pulls in all those logs and puts them in one place. Then it layers in the latest AI-specific threat intelligence. Next, it uses special rules to connect the dots and spot really complex attacks. And finally, it kicks off automated playbooks to start responding to an alert immediately. You know, a quote from the source material really just nails it perfectly. An effective SIEM gives security teams that complete visibility across the entire complex AI infrastructure, and it does it while automating all the boring stuff so they can focus on the real threats.
All right, if you forget everything else from this explainer, please remember this one thing. Continuous, multi-layered monitoring isn't some nice-to-have feature. It is the absolute operational backbone of modern AI security. Without it, you are completely flying blind. And I'll leave you with a final thought. If your organization is trusting an AI to make critical, high-stake decisions about your business, your customers, maybe even your money, shouldn't you be listening very, very carefully to everything it has to say? Thanks for joining me.